And looks like we are live. We are live again today, everyone. Back to another morning full of calculus 2. Crazy. And here we go. Yesterday we did not get to finish our homework because we had to leave for piano class. And today we're determined to finish our homework today. Let me share my screen, and I don't think I needed to ramble on for about 5 minutes before I begin. So as you can see, we have 4 problems finished, and we have 20 problems. We have 17 problems left, so that's why we got to get to it. So today's method is going to work a little differently, because I see that we're usually spending a few hours on all these problems. We don't want to spend as much time doing every single of one of these problems, and I believe that we still lack the skill of recognition. For example, all these problems have to finish these problems, you need to recognize what identity to use, where to substitute, what to substitute, and that part takes a lot of time. So in order to both speed up and to improve my pattern recognition ability, I'm going to be using Copilot. I'm going to be using AI. And I told him what I struggled at the most, which is, I believe, the hardest part for everyone who learns these topics. It has to do a lot with substitution, use substitution. So I told him whether he can explain the rationale and the approach for every single problem I present him with. He'll tell me the verdict and scope. He'll state whether the integral is best handled by use substitution, trigonometric substitution, algebraic manipulation, or a combination. And I think that this is super important because I see that the algebra, the integral part, just solving the integral with the power rule is the easy part. I already know how to do that. That's easy. It's just a computation. Right here, what we are looking at is substitution, a combination of algebra and all of that. So this is really important to understand why it is best to use substitution, trig substitution, or algebra for certain problems. If you don't specify, I'll assume an indefinite integral in a real variable domain. Gotcha. Okay. Step 1, identify structure. I look for patterns. A clear derivative of an inner function suggests u sub. A square root or a quadratic suggests trig sub. Gotcha. Rational functions, that's partial fractions, or trig products use trig identities. Pattern recognition reduces choices to a small set of standard tools. I agree. Step 2, choose the substitution and justify it. So he will choose u substitution. He'll pick u so that du appears in the integrand. So it should be up to a constant. So the derivative should be constant. He will show me the algebra that makes du appear and why that choice simplifies the integrand. So u substitution is essentially algebra. That's very important to understand. It's not a lot of calculus. It's hard algebra, but it's just algebra. And the purpose of using u substitution is to simplify the integrand, the function in the integral. He will use trig substitution if he sees one of the 3 forms, a squared minus x squared, a squared plus x squared, or x squared minus a squared. I think I understand a lot about these. This I'm much more familiar with. I think the u substitution is the hardest part. And he'll explain the rationale. That's very important. It'll help me a lot. Choose which trig identity to apply. Okay. Oh, that is also super important. I'm always confused why you choose to substitute for sine and not cosine, or the converse, right? Handle differentials and constant, integrate and back substitute, check, and no pitfalls. Very cool. So this structure looks super cool. It looks super efficient. And I'm actually really excited for everything that I'm going to be learning. Now I'm going to get my iPad, which is right here. I was just charging it because you got to have a good charged iPad for a long math session right now. There we go. That's good. 66%. At least it was not 60, folks. So here we go. Here we go. As you can see, my iPad is split into two parts. First, we have where we're doing our calculations, we are writing the integral and all of that. And then up above, we have our notes. For example, here is the table for the trigonometric substitution, and that explains why I can understand them well, because I can clearly visualize it in this table. And it really helps me. It really helps me. Here we have the expression, the substitution, the identity, and simplified. And I created this all myself so I could reinforce everything I was writing. So that's what we're going to do today. So here we go. So we have question 5. So I'm not automatically going to use Copilot. I'm going to see if I can solve it myself. But I believe I have a long way to go in order to solve these myself. So I'll probably use Copilot frequently, but not at the beginning. So here we go. Let's begin. We have the integral from 0 to pi over 4 of sine to the power 4. That looks like it. That's weird. Sine to the power 4 of 4x dx. Bro. Perfect. So what's the first step? So we do not have two products to use integration by parts. We don't, hold on. When did I begin this? A18, yeah. What else do we not have? Let's see, we have a definite integral. So, yeah, it's still going to work the same way. What else we have? So we've sine to the power 4 of 4x. So let's just go with our gut. We don't exactly understand why, but we probably will find out something if we just go for something. So the indefinite integral of pi over 4 sine to the 4th of 4x dx is going to equal, we can probably split into 2. Maybe we could do, or in fact, maybe we could use u substitution. I think there are 2 ways that we can go and do this question. We can either split the power 4 of 4x into like 2 sine to the power 2 sine squared of 4x. So maybe we could use an identity. All right, and what would that do? If we were to do that, what would that do? We could replace 1 minus cosine squared of x, but I don't know if that's going to help us anymore. I believe u substitution is going to be the best method to use right now. Oh, great. So if we let u equal to, I don't know, 4x, let's do that. Thus, du is going to be 4 dx. Excuse me. So therefore, dx is going to be 1/4 du. So by taking out 1/4, we will get 1/4 times the integral from 0 to pi fourths. Oh, wait, by the way, am I sharing my screen? I'm not even, oh, I am sharing my screen. Oh, let's go. 1/4 times the integral, the definite integral from 0 to pi fourths of sine to the power 4 of u, oh, hold on, yeah, of u du. Very cool. So that's what we have. Maybe now we can split, let's see. What's a good idea? And I don't want to be stuck in this forever. Yeah, I do want to think about these problems very well. Let's see. Oh, wait, I'm so stupid. I think we can just do the power rule or something, right? I believe, okay, so first of all, what will our antiderivative be? The antiderivative of, oh wait, but we have sine to the power 4. Does that still apply? No, we can't use a power rule there, of course. If we do negative cosine, let's see. I want to see the first step that they do. Can you begin by using a half angle identity to rewrite the integral? Okay, looks like they don't use U substitution first. They will use a half angle identity. So I believe I'm going to ask Copilot why we are going to use a double angle identity, because I really have no idea why you're going to use double angle. I mean, it's just it does not make sense. But let's do it because we clearly can. That was one of our two choices that we contemplated. So we get. Oh. Why isn't this working? Hello? Great. There we go. So let's see. So we have the integral from 0 to pi over 4. And we can split. We can split the sign. So I believe we get something like sine squared of 4x times sine squared of 4x dx. And we can now substitute our half angle identity, or just replace. I'm not even sure if that's considered substituting. So sine squared to the power of 4x, what's that going to be? Sine squared to the power of 4x, that's 1 minus, yeah, 1 minus, whoops, 1 minus cosine squared of 4x. Excuse me. All right, I hope I did it right. So, okay, they split it into two, exactly what we did. But then, oh, whoops, we forgot the 1/2. How could we forget the 1/2? Wait, no, hold on. Why do we have a 1/2 though? Don't you only use 1/2? Okay, hold on. Let's look at our notes again. Sine squared of x equals 1/2 1 minus cosine of x. But at the same time, sine squared of x equals 1 minus cosine squared of x. What's the deal here? Isn't that contradictory? Oh, I see. Oh, interesting, actually. Okay. So it looks like we're going to do that. Gosh, dude, these identities, I'm telling you. And it seems as if we are rewriting each sine squared of x. So that's what we're going to do then. So we have 1/2 times 1 minus or plus? 1 minus cosine squared of 4x times the same thing, right? Because sine squared of 4x the same thing as sine squared of 4x. Great, dude. Dude, why does this keep happening? Is this Canvas fault? 1 over 2 times 1 minus cosine squared of 4x. And of course, we have our dx. Very cool. So now what? Looks like we take out, we have 1/2 times 1/2 is 1/4. We take that out. 1/4 times the integral, the definite integral from 0 to pi over 4 of 1 minus cosine squared of 4x times 1 minus cosine squared of 4x dx. Very cool. And then it's telling us, now can you use another half angle identity to evaluate the integral? Let's see. Oh, wait, hold on. What did he do here? 1 minus 2 cosine. Oh, you expanded, didn't you? I mean, did you? Whatever. Let's do that. Let's see. Yeah, looks like it expanded. So 1 times 1 is 1. 1 times negative cosine squared of 4x is negative cosine squared of 4x. Oh, so and then that again. So 1 minus 2 cosine squared of 4x plus cosine 4 to the power 4 of 4x, right? What? Why don't... Dude, I'm so stupid. Hold on. Wait, pause. Okay, hold on. Sorry. This is important. So we have sine squared of 4x. That is equal to 1/2 1 minus cosine of 4x. Wait, but you... Oh, wow, we are missing a bunch of things, guys. Of 8x, but we remove the power of 2. All right, this is good. This is good. Excuse me, got some bubbles in the throat. So now, yeah, so let's get rid of these squares. 2 cosine of 8x plus cosine squared of 8x. Oh, there we go. So there is where we can use the next half angle identity. Let's do that. So we can have something like 1 minus 2 cosine of 8x and cosine squared of 8x. So half angle. So that's the 1/2 one. So we can rewrite that as plus 1/2 times 1 minus cosine of 2x. Oh boy. Cosine of 16x, I believe that's... Okay, wow. So if we got that wrong, then we should have gotten something else wrong over here. No, it looks correct. It looks correct. Let's have faith. Very cool. I believe we're going to get in the dx, of course. So, did we get it right? And then 1/2, 1. Oh, wait, why did you do plus? Oh, that's right. It's minus when you have a sign. We got minus here. Oh, that's right. That's right. I forgot. So, yep, plus, that's what we get. You double it. Perfect. Then yeah, so we can take out that 1/2. We get 1/8 outside of the integral. Let's just rewrite it quickly, making sure that we don't get any errors. Dx. So now I believe he wants us to simplify, right? So we get something like let's see. So we can just... So let's do 1 plus 1 minus 2 cosine of 8x plus cosine of 16x dx. So we have 1/8. We take out the 2, we get 1/4 outside the integral. what am I doing here? Oh, right. So now we don't have any squares. So I have one question. Let's ask ChatGPT this time. Um, let's see. Let's see. I have an integral. Use integrand. Excuse me. Um, oh, okay. I thought we were up to something. Oh, bro. Okay. I thought I thought we were cooking, but no. We got back to being humbled. Right. Wait. Whoops. Okay. Okay. I think I see. Cheer. Oh, hey. What's up? Me, I'm a college student now, so I'm taking this calc course in ASU. Yeah, thank you. I'll thank you a lot. Make the family proud. Oh, Gemini is better. I think so. I tried installing Gemini one time, but I think you have to do like a free trial or something. So that's why I'm just using this one I already have. But yeah, I mean, I bet Gemini is good. I've heard a lot of good things about it. I guess I'll consider it probably for next time. Thanks for the recommendation, though. Yeah, where were we though? So we have um so you got three. Where do we get three? Right. Let's go back up. So we had one minus two cosine of 8x plus one half one plus cosine of 16x, the double, right? And we had one fourth outside of the integral. We took out the one half and we got 1/8, 1/8. And now we have 1 minus 2 cosine of 8x plus 1 cosine 16x. But why is there a 3 there? So, hold on. Oh, wait, and by the way, how did he... Oh, so did he divide by 2 everything? Oh, or sorry, multiply by 2 everything? That's probably what he did, didn't he? So he multiplied this term by 2, and then he probably... This is 2 minus 4 cosine. Oh, that's right. So I'm going to delete all of this because it's trash. There we go. So what did we have? Oh yeah, and this also needs to be deleted. So we have 1/4. The integral from, oh, in fact, we have 1/8 because we multiplied everything by 2. 2/4 of, so 2, because we multiplied everything by 2, 2 minus 4 cosine of 8x plus 1 times, so whatever, 1 plus cosine of 16x dx. Oh, wow. I need to blow my nose. That's much better. Okay, all of this looks good. So now let's simplify to get what they get. Cool. Yeah, let me just get it right. Yeah. Let's see. So now, 2 plus 1, that's 3. Then we have minus 4 cosine of 8x. Plus cosine of 16x and all that dx. Very cool. Yeah, so now finding the antiderivative looks much easier. So we have 1/8 times, so the antiderivative of 3 in terms of x is 3x. Oh, hold on. Well, okay, so I'll just write it down here. So we have a 3x minus 4 sine of 8x over 8x, right, yeah, right, plus sine of 16x over 16. Okay, so yeah, just simplifying. You get 3x minus sine of 8x over 2 plus sine of 16x over 16. So now doing our antiderivatives, we get, so our upper bound is going to be pi over 4. So we get 3 times pi over 4 minus sine of 8 times pi over 4, all of that over 2. Okay, plus, look at mini bracket right there, plus sine of 16 times pi over 4, all of that over 16. Close a bracket, and then we got to do minus the 0. So 3 times 0 minus sine of 0 over 2 plus sine of 0 over 16. Close and close. Very cool. So entering our results, we get 1 over 8 times 3 pi over 4 minus sine of 2 pi over 2 plus sine of 4 pi over 16. And that's correct. Let's go, everybody. That was super cool. Let's go. That was good, but let's continue. So, hold on. Wait, well, even though we got it right, I want to understand why we had to use, what was it? Identity? Some good help. Gotcha. Gotcha. Okay. I see. I see. Okay. Makes much more sense about why it was best to use half angle identities. And I believe that we have gained a little bit of confidence to understand. Sorry, to keep going. To keep going. Well, let's continue because we still have 15 problems left. Oh boy. And I was thinking about playing the game, the snake game. Haha. We can do that maybe after 10 problems or something. Let's go. Who's this guy? Okay. Okay. Let's continue. So we have to evaluate the integral of secant square root of x times tangent of tangent to the power of 6 of x dx. Very cool. So this one, obviously, we see the pattern secant tangent, and the antiderivative of that is simply secant. So that's pretty cool. So what we're going to do, so we have powers. So I believe we should split them. Watch me cook, guys. Watch me cook. Oh, my breath so fast. Very cool. Now what's next? So I believe substitution is next. U equals what? Let's say U equals secant of x tangent of x. It's fine. I'm not quite sure. Let's see. Oh, so you begin with substitution this time. Bro, brother. Oh, interesting. Interesting, bro. Okay. Okay. I think I understand a little better. Okay. Very cool. Oh, bro. Let's continue. Isn't 8 pi over 4 simply 2 pi? Okay, everyone. I think I know what to do. Half angle identity. Want to know why? Because we see a power here. U substitution is not going to help us decrease that power. So, yeah, I guess that's it. And that's it. Thanks, everyone, for listening. So, okay, let's see. So, secant. Boom. There it is. So we get oh wait, and this is dt, isn't it? dt. There we go. All right, we gotta go fast. So, what's next? Whoops. Let's see. So now what? Well, let's expand. Oh wait, what? Hold on. Oh, bro. So I guess, oh, darn it. Oh, that might work actually. Okay. Perfect. Get dt. The derivative of the inside function. 1/8. Oh. And why is that? What about the 1/7? Okay. Okay, gotcha. So now, what's tangent? Sine of pi/4 is √2/2 over, and cosine of pi/4 is also √2/2. So 1. Oh, very cool. Okay, so that means that that's du, okay? 1 plus. Oh, wait, so I was right. So hold on. So t over 8, the derivative of t over 8 is going to be, well, 1 over 8, right? So, bro, you're right. It's just 1 8. Uh-huh. Oh, bro. Don't we have to replace u, though? Oh, hold on. Or is it times 8? Yeah, times 8. Okay. Yo, we almost had. Let's go. We surrounded the snake. Oh, darn it. Let's go. Oh, darn it. Oh, oh. Okay, we'll play one more game and then we'll be back. Uh, oh, let's go. Yo. Oh, okay. That was fun. Yeah. Okay. So we're back. We're back. Here we go. So let's see. So the derivative of tangent of 4x is secant squared. Mm. Oh. Okay, get it. Equals tangent of x, okay. Very cool. I see. Okay, smart. And for this one, so you guys, I'm crying because it's too hard. That's kidding. I'm not. I just yawned. Let's see, bro. So u equals, okay, well, first of all, what do I have? So I have secant squared of t over 8 times 1 plus tangent squared of 2 over 8. if I let u be tangent of 2/8, then du is going to be 1/8 times tangent squared of 2/8. So then I'll get u squared, or 1 plus u squared du, and the 1/8 goes outside. Gotcha. Bro, what's going on? Oh, I thought I was there. That was dumb. Oh, gotcha. Okay. So let's try that. Hmm. Yes. All right, and then we can let U be. What should U be? You can be. Hmm. Uh. Oh wait, no. That's easy. If we let U equal secant squared, yeah, no, we want to let U be tangent of x. There we go. Whoops. Cool. Mm, oops. Let's see what else. Presence. Mm-hmm. Why do you, bro? Some more, yeah, more calculus here. Just can't square this tangent. That'll be, hold on. That'll be, secant square root of 4x. X, I believe. What is u? Tangent of x. This is correct. For real? Oh, let's go. We're so good, guys. Dan is right. It worked. I know. I was like, I must have made like an algebra error on here, but no. Let's go. Right? Yeah. Hopefully I can be a little more attentive in this next problem. Yeah. Well, dude, you're like my most loyal a commenter in my live streams. Thank you. Thanks for being here, dude. Really appreciate it. So let's see. Tangent cubed of 3x times secant to the power 5 of 3x dx. Let's see. Well, we have like an odd power. Let's get some help, shall we? Is odd. That's it, guys. I'm gonna do something. Let's see. Can we open a new page? So odd. In fact, look, let's use the pen. Odd exponent. Let's put a table. Oh, actually, yeah, that's a great idea. Very cool. Okay, so now. Oh, awesome. So I think that now you should use u equals, and that'll be, let's see, what if we do u equals, the derivative of secant is that. Let's do u equals secant of 3x. Du equals secant of 3x, tangent of 3x, dx. Oh, so stupid. We forgot the 3. So let's do divided by 3. Awesome. So now we get, whoops, 1/3. And we do, and that's du. Awesome. Okay, so we get du. Okay, that looks much better, but we still have that tangent squared of 3x. That sucks. Let's see how they do it. Let's see how they do it. So, okay. Oh, okay. We were close though. We were close. But no, we don't do that. What we want to do, and it appears so that the tangent squared of x. Oh no, I actually think, no. We were correct. Actually, we were correct. -1. There we go. Cool. And we did u equals secant of 3x. Oh, very cool. So now we replace u again. U squared -1 times u to the power 4. Let's go. We did it. Yes. We're so good. Yay. And u is secant of 3x. Very cool. I did not even need that much help. I mean, actually, I was correct on most things. Oh, what? What happened here? Oh, I'm so dumb. All right. So there we go. That looks much better. Let's go. Let's go. Yes. 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 Thank you, dude. I was also streaming yesterday. Yeah. Oh, you brought your friend and let's go. Oh, applied physics, but that's also tough. Oh, thanks, guys. I appreciate it. Thanks for liking the stream. and another brain rot content. It's going good, bro. Thanks for coming. I really appreciate it. I think the more people come, the faster we complete the problems. Yeah, it's a good day so far, especially that we completed this problem pretty quickly. How are you doing? Let's go, dude. Thank you. Oh, so are you guys also like math nerds or anything? Do you guys like math? I saw that you guys did applied calculus and physics. Yeah. Yeah, dude. Yeah, go ahead. Oh, cool. Okay. Gotcha. Are you guys like in high school or middle school? Because applied calculus and physics, that's pretty advanced. Wait, so are you guys like, college? Gotcha. Okay. All right, cool. Yeah, cool, guys. Yeah. I just finished high school. Yeah. Okay. Well, very cool, guys. Oh, not college? Oh, well. So you finished high school, but you're not in college yet. But NAB is in college, right? I think that's what I understand. College and high school. Okay. Vacation. Cool. Yeah. Well, I hope you guys enjoy the vacation. I mean, I think they're also very important. Oh, okay. Oh, yeah. Like, are you guys like from India? Or was it? Forgive me if I got it wrong, but I think I think Nab said something like that. So it's probably different there. I don't know. I might be totally wrong. So please correct me if I'm wrong. 11 or 12. Okay. Cool. Gotcha. Well, cool, guys. I hope you guys enjoy your vacation. Yeah. And also, all right. All right. Right, gotcha. I'm just making sure. I'm just making sure that I understood what you guys said. Yeah. Well, very cool, guys. Thanks for being here. Let's see. We have 11 questions. So still gotta focus. Oh, okay. Looks different here. But yeah. Oh, it'll end in a week. Oh, that sucks. Well, I'm sorry, but that's actually a little early. It's only like May or something. But okay, I guess you guys also must be busy. 4 days. Cool. Well, I hope you guys enjoy the rest of your vacation, okay? Yeah. Me? I'm from the US. So I think vacation started for everybody a week ago. And I think it ends in a couple months and a half. Yeah, it's cool. It's cool. I like it here. It's pretty easy to concentrate. Concentrate. It's pretty sunny though, so it kind of makes me want to go outside. Yeah. Is it sunny where you guys are right now? I wonder what time it is there. Hmm. Oh, raining. Wait, is it not raining or is? Oh, it's night. Oh, okay. Oh, fun. A night in rain is actually super fun. A great time to watch a movie or something like that. Or it might be a very cooler to focus with calculus in the night and raining. Oh, your summer just ended. Okay. Oh, gotcha. I see. Okay. Me, yeah. I'm in college. Uh, I'm in ASU right now, Arizona State University. Yeah. This class is just one of the what one of the math classes I have to do. Yeah. So your summers end early? Oh well, that was 3 months ago, but now I'm in college. I said I was in 10th grade 3 months ago. Oh, okay. The thing is, like, I mean, let's see. I was in 10th grade, but I graduated. Like, I had all my classes complete, so I could basically just graduate. Yeah, yeah. I guess it's gonna be confusing. Yeah, I mean, I did say I was in 10th grade. What the heck? Is in college now, so I see. Well, yeah. I mean, I'm officially a college student now, so it's pretty cool. Yeah. Oh no, well, I mean, let's see. In the U.S., we do have 11th and 12th. I just skipped them because I'm homeschooled and I completed my classes early, so I could do that. Yeah, but if I wasn't homeschooled, I think I'd have to do 11th and 12th. Yeah, that's how it goes. Hey guys, well, thank you for joining Asian. I think. Let's see. Uh, I think for sure Asians have have like a bunch of rigor that maybe in the U.S. we lack, especially early on. I mean, like I've seen that like a lot of Asian countries take education very seriously. So that for sure is something. A lot of kids are probably more academically serious than here. I for sure see that. I'm not sure if I would say like the education is better since I think this is different. I mean, probably the different cultures. I heard that like in China, I think you have to take like a test in order to get a job, and it's pretty serious. And advanced curriculum, right? Yeah, probably in Asian countries, a lot of you guys do a lot of advanced curriculums, so that's for sure. Yeah, well, probably in that sense, China's torturing kids. I saw this video where like a bunch of kids were like depressed and sad. I don't know. Well, no, I mean, um, of course, I also think it's cool to enjoy some days. Like, not every day has to be a very serious. What do you think? What do you think? I gave my opinion. Oh yeah, I mean, you said that Asians have advanced curriculum, so probably in that sense, Asian education could be better than in the U.S. All right, cool. Well, thanks, guys. Are strict. Okay, gotcha. Oh, well, if that's the case, then I mean, probably the schools between the U.S. and Asia, I guess they're different. I don't think the schools here. I mean, I went to school and I don't think it was very strict. I don't remember it being a very strict academically. Oh, so cool. All right, dude. Well, keep it up, and you'll probably be more advanced than like a lot of the population. Gotcha. Oh, you guys learned the structural model of an atom. Okay. In third grade. Yeah, I don't think we see that until like middle school or something. That's a cap. Oh, in China. Okay. He's lying. That's so funny. So, are you guys like from the same place, or are you guys just friends online? Okay. Oh, all right. Cool. Cool. More guys. Oh, we used to be classmates. Fun. Yeah. I don't think I remember a lot of my classmates. I mean, I know my cousin. He used to be my classmate until this year. Okay. Very cool, guys. Yeah. Well, I think I should go back to finishing my problems, guys. It was super fun talking, but I think I gotta focus now. So I think I'll talk to you later then. All right. Yeah. Thanks for talking, guys. It was a lot of fun. Whoops. Here we go. Cool. Let's continue. For each of the indefinite integrals below, choose which of the following substitutions would be most helpful in evaluating the integral. Ooh, I think I remember this one. Let me just pull up my table. If you prefer derivation to memory, recall cosine squared of theta plus sine squared of theta equals 1. And by dividing cosine squared of theta yields 1 plus tangent squared of theta equals secant squared of theta. Right. Let's see. So let's begin from number 6. We have a squared minus x squared. So that looks like a case for a sine of theta. Where's sine? So we have the sine right here. Oh, this again. Oh boy. Hold on. So 49, 7. I think 7 should be in the denominator, but we don't see that anywhere. So k, I believe. How about for this one? We have x squared minus a squared. So we need a secant of theta, a secant of theta. So I think we need 3 secant of theta. Or do we need 1/3 secant of theta? Hold on. What is a? A is 4. So if a is 4, then we need, oh, I see. 4 times 9, 4 times, hold on. 4 times 9, x times 9. What times 9 is 16? Oh, there we go. So that'll be 9/16. 9/16. No. Oh boy. Yeah, I'm clueless. So here we need a secant. All right, well, we need at least a secant. So we have 2 secants right here, a couple of secants right here. So what works? If we have secant of theta times 3 halves, what happens there? 3 halves. Now we get 18 halves and 9. Wait, what? Oh, for real? Sorry, 3 times 9 is 27. 27 over 2. 27 secant minus 16. I don't think that'll help us. If we have 2/5, that's 18 over 5. That probably won't help us as well. And we have 5/4. Oh, 4/3. I think that'll help us. 3 times 4, 12. All right, I'll say E, because why not? 9 plus 16x squared. I look like a big old case of tangent of theta. What is A? A is 3 or divided by 16. I think that's the case. 3 over 16. Hold on. Or 9 over 16. Dude, I don't know. I mean, oh my gosh, bro. I don't have the foggiest idea. Hold on. Are these correct? Oh, they won't tell us. Let's get some help. That's it. I'm going to ask Copilot to give me a reason for each answer. Oh, whoops, but I also need him to know the answers. All right, I'll finish this and then I think I'll go eat breakfast. So we have that. So, okay, we have like x squared minus a. Oh, hold on, wait, x squared minus 9/4. So 9/4. Oh, actually, yeah, 9/4 square root of that, that's 3/2. And because when there's this, yeah, 3/2 secant. Where's 3/2 secant? 3/2, 3/2 secant. That's I. Makes sense. All right, applying that same logic here. So we have 25 and we have 16. So here we have a squared plus x squared. So 25 over 16, what is that? We take the square root of that, we get 5 over 4. We need 5/4, 5/4 tangent. That's B. We're cooking. That's actually much easier than we thought. So, oh wait. No, I think that's good actually. It doesn't matter. Now we have 4 minus 25x squared. Divide 4 by 25. That's 2. That's 5. 2/5. 2/5. 2/5 sine. 2/5 sine. That's C. Finally, here, 9 plus 16. So x squared, x squared. Wait, and this is plus, plus, plus. So we need a tangent. We need a tangent of theta. 9 over 16, 3 over 4. 3/4. 3/4. That's D. Here, we have x squared minus a squared. 9x squared. We need 16 over 9. That is going to be 4 over 3. Looks correct to me. Let's go. Let's go, everyone. Now we're back to evaluating integrals. Use Grok. Oh, Grok is actually a good idea. Not bad. Yeah, a Grok is a good idea. What do you think? I'm with Copilot right now though, because it's working. But yeah, I mean, I think a Grok is actually more mathematically rigorous, probably. So, yeah. All right, we're 50% of the way there. Maybe it's time to eat breakfast. So I think I will see you all after breakfast. Cool. I'm just going to turn And we're back. Yo, the comment section is going crazy. Let's go. Oh, what is my dog doing now? Oh, it's YouTube. Oh, cool. Bear, no. Bear, oh bear. Bear. You're in the last one, buddy. You good, buddy? There? Buddy, look. You guys look at the bear. I say hi to bear. I'm back. Yeah. Oh, it's bear. He's out. Now it's time to lock back in. Cool. We go 2 hours and 39 minutes. Okay. So let's play a little bit of this game and then we will go back. So let's go back to poop. So how are you guys doing? Are you guys having a good day? Whoa. Oh, I died. All right, there you go. We'll do this game and then we will log back in. Let's just try to win. Oh, look. Oh, free food. You guys know I love free food. You know, free food is so cool. I mean, who does not love free food? He almost crashed into me. Let's go. Let's go. Oh, okay. Well, that's probably enough. All right, cool. That's awesome, man. Yeah, I'm glad you guys are having a good day so far. Because now it's time to log back in. Let's go to a second focus period now. Okay, let's do this. So we have the definite integral from 0 to 7 of x cubed times the square root of x squared plus 49 dx. So this looks like a trig substitution problem. We have x squared and then we have a squared right here. I like it. Let's do it. So let's see. Okay, so first we will let x be 7 tangent of theta. So what does that mean? Okay, cool. I like that. So let's replace the definite integral from 0 to 7 of 7 cubed tangent cubed of theta times 49 tangent squared of theta plus 49. So here we can good old factor. So then we have 7 outside, because if we factor 7, we get tangent squared of theta plus 1. So let's see. So I think this equals to secant squared of theta. I think so, right? Yeah. Oh, yeah, it does, according to our notes. So 7 secant. And that's how we take out the square root. Okay. Oh, interesting. So now, okay, so if we take out the 7 to the power of 3, so we have 216 times the integral from 0 to 7 of, oh, wait, hold on. Actually, this looks 2 to the power of 4, 7 to the power of 4. 7 to the power of 4 times secant of theta tangent of theta. Well, the derivative of that is only secant, I think. Yeah. So we have 7 to the power of 4 times secant of 7 tangent of 7 minus secant of 0 tangent of 0 plus c. Cool. Plus c? But c is not defined here. Yeah, okay. Let's see. Wait, why no plus c? Oh, whoops. Wait, no, whoops. Secant, right, yeah. That should be correct. Okay. Now let's see. Oh, hold on. I think I know. Did we forget to replace dx? So dx is going to be, oh yeah, that was important. Dx